Hello everyone, welcome to the next class. In this class, we're going to talk about the structure of Linux directories, okay? Not just Oracle Linux, but you see this structure in other Linux distributions as well, all right? It's the same idea. And here I'll explain what the objective is, and we'll take a look at the contents of these directories, okay? So, well, the first directory, as we've seen, is the root directory, where all the programs of Linux are installed. From this directory, you'll see by default that the main software, right, of Linux itself will be installed inside directory starting from the root directory, right? If you come here to the root directory and you type L, the ls, you won't see files here, okay? By default, you'll see directories that already came from the Linux installation, okay? Some of these directories, well, not some, all the directories are already here. So the purpose of the root is just, the origin. From there, all the other subdirectories are being created. They will be created. The root user itself, right, has access to this directory. Other users, they don't have access to this directory, right? And root can create files inside the root directory. I just created a little file here, look, with no content, using the touch command, okay? Here it is, look. I know it's a file because it's blank, okay? White text. Other users, they don't have the option to create files in the root directory, right? So let me delete it here. So this directory doesn't get cluttered. There's also the home directory. Every user who accesses it, every user created in Linux, when they log into Linux, right, by default, they enter the home directory, right? That's their home. And that's a place where users will create their own directories, their own files, okay? Many times they might even install things in this directory, which isn't very common, but it can happen. But then the home directory is the place where users who are going to work with Linux will create and keep their files. All right? The bin directory, which is under the root, that's where we have all the binaries, right? All the executables of the Linux software, okay? So the main commands, for example, nano, the binary for nano, the eases of nano will be inside this directory. But nano doesn't have just one file, right? It doesn't have just the exes, let's say, like it would in DOS. I'm saying exes. So you can understand if you don't already work with Linux. But yeah, nano will be inside that directory. But all the other files needed for nano to work will be in other directories. But here is the place in this bin for you to check the main Linux commands, and also the place where no matter which directory you're in, okay? By default, when you run a command in Linux, for example, call a program, and that program is a file. Linux will look for that program inside the bin. When you type nano, even if I'm here in the root, the Oracle, through a variable called path that we'll see, it looks by default for the binaries inside this bin, okay? So if you were to run here, look closely, cd bin, and then you were to execute an ls command, you will clearly see will be able to thoroughly check all the various binaries that inherently exist that are indeed installed within the Linux operating system. Okay? These specific entries here are essentially the names of the executable programs. All right? As you install new programs, the executable, the main program will be placed here, and the files, the other files that this program needs to run will be in other directories, but here is the place where the name of the executable will be. That's how Linux works, okay? If you were to run a command here, look, specifically lsb nano, you would clearly see that it is indeed located right here. Do you understand? There is the program nano, which is precisely situated inside the bin directory. All right? There's also a subdirectory called root, that's /root. Inside it, there will be programs and files that can only be viewed, okay? And only the root user can create files in there, all right? Just as regular users typically cannot directly see or access the root directory, users also generally do not, they inherently lack the default permissions to read, write, or create new files within the confines of the root directory itself. Okay? Only the root user or system administrator with elevated privileges has that capability, right? So if I do a cd/root here, I'm inside the root directory, which is the home directory, okay, for root. So if root runs an ls, you can see, okay, the files that are in there. But there are files that are hidden in there for security reasons. So if we run lsa uppercase A, we'll see files that are hidden because these are files that could have an impact on security issues, so they're hidden by default. There's also the boot directory, which Linux uses when it restarts Oracle Linux itself, okay, on Linux itself. It's an important folder that you shouldn't modify or create files in, right? Unless you have experience and know what you're doing, because you'll be changing the way Oracle Linux performs its initialization, its startup, okay? There's also a directory called dev, which is short for device. So in Linux, everything is a file. Everything is managed as a file. Even physical devices, for example, printers, disks, network cards, everything in Linux is a file. And you can modify these files, and that will impact the physical devices that are connected to Linux. For example, a disk, all right, you can attach a disk, and then you'll need to do some configurations, and those configurations will be inside this device directory, okay? You can easily create a new partition on the physical disk, and you can thoroughly check how the Linux operating system is configured and how all the various devices are set up inside this specific device directory. Actually, Linux effectively manages these various devices, these physical hardware components, treating them as files inside this particular directory structure. As you make configurations through other programs, those settings that change how Linux interacts with this hardware will be stored, those parameters will be inside this directory and within the files inside this directory. So for example, if you were to run the command cd/dev and then subsequently perform an lss command, here for instance, these are indeed the various disks, okay? Or perhaps even the partitions themselves. So here I have a dedicated directory specifically related to the server CD-ROM drive. where you can, through specialized software applications, effectively configure and manage the server's optical CD-ROM device, right? The ports in Linux, in short, these are files and directories that manage the physical components integrated with Oracle Linux, okay? The etc. directory here in Linux is where it keeps the general configuration files for all users. So when you make a configuration change and modify a parameter, okay, and you want that configuration to apply to all users who will access Linux, those parameters, those files are kept inside this etc. directory. All right. If you want to make a specific configuration that only applies to a particular user, right, it will only affect that user. Okay? Those configurations will be stored inside the user's own home directory. So here, I'm currently inside the etc. directory, which is a very important system directory. Consequently, I've observed several distinct directories located within this particular path. I am well aware of this fact because of the visual cue provided by the color. Specifically, they are prominently displayed in a clear blue hue. And inside these directories, I can have new subdirectories, or I can have configuration files related, for example, to a library, right? I know that because it says lib here, or I might have, look, various configuration files located here that are directly related to the specific login definitions and their associated parameters. So these are general configurations that will apply to all users who access the Linux server. Here I have configurations related to printing. All right. So there is a specialized software application, okay, that provides us with the essential capability to meticulously schedule the automated execution of various scripts and commands within the robust and widely used Linux operating system environment. This allows for precise control over when and how tasks are performed, ensuring efficiency and reliability in system management. We saw back in the Windows lessons that we can have Windows automatically perform certain tasks at a specified day and time using the task scheduler in Windows. Linux has a command, a program that serves the same purpose as the task scheduler in Windows. This program is called crontab. All right. It even meticulously maintains its own internal files where you can readily use various programs to precisely execute a specific script at a certain predetermined time or on a particular day. And this crontab uses that file. So if I run a cat crontab here, we can check, okay, the contents of this file called crontab, right? The program is cron, okay, and it maintains this file, where we later on will see this further in the course. We'll set parameters so that Linux can execute a specific task. For example, an automatic Oracle backup if we wanted to. If we didn't want to use, for example, RMAN, we could export tables, right? Using, for instance, cron. There are also several other important directories, specifically library and library 64, which are dedicated folders where the Linux operating system meticulously keeps the essential 32-bit or 64-bit libraries, right? These are crucial to be effectively utilized by various Linux programs or by any other applications and programs you might choose to install on your Linux system. For example, something like Oracle. Okay? So there are these two directories where Linux stores the libraries. There is also a directory called /opt, which is short for optional. And when you, for example, buy a Linux system that already comes installed on a server, on a machine, right? You bought a server, I don't know, maybe an IBM or some other server, and the manufacturer, along with the server, already provides Linux installed and some pre-installed software as well. All right? So these pre-installed software programs will be in here. They might be in here, okay? But it's also possible that they were installed somewhere else. But many times manufacturers install software, right, that they will deliver along with the server and keep it inside this OPT directory. Linux keeps this directory for that purpose. You can use it or not. There's also a TMP directory, right, where Linux will keep temporary files for as long as it thinks is necessary. Usually, when you reboot or restart Linux, the system itself deletes files in that directory that are no longer needed. But on many occasions, during the installation of some software or while running some software, Linux may create temporary files inside this folder. And this folder is actually an interesting place for you to check from time to time to see if Linux is really cleaning up what's inside, okay? Because it can fill up with a lot of files that are no longer needed and can take up space on your disk. All right? This also happens in Windows. Same thing. So this is indeed the standard and typical structure, okay, for virtually any Linux distribution that you might encounter or utilize. Any Linux distribution, or at least the main ones, right, the most well-known, will follow these three, this hierarchy, and these directories will exist, okay? That we've seen here, that are right here, it's the etc. It's the lib. It's the lib64, which are under the root, is the apt, okay? Is the root, right? It's kind of standard for all distributions. And these are the main directories. So I'm going to pause here for a moment. And in the next class, we're going to perform an operation that's very important for you to do, especially after you install Oracle, or from time to time, it's a good idea to carry out this operation, which is updating the packages, right, of Oracle Linux itself. Many times you install it, but there's already a newer version or some package has already been patched. So it's a good idea after you've installed it, depending on how much time has passed since you downloaded the Linux ISO and didn't install it immediately. You downloaded it and then 2, 3, 5 days later, you go to install it. It could be that during that time, Linux or Oracle in this case, or any other distribution has already updated one of its packages, fixed an error, or addressed a security issue that was identified. So it's a good idea for you to update the packages that are installed. We'll take a look at that in the next lesson. So first, how exactly do we go about checking and subsequently updating the repository that is already present within your Linux operating system in order to ascertain if it is indeed fully up to date or perhaps not? In other words, you are going to execute a specific command, an essential update command, and at that precise moment, the Linux system will diligently check if the installed package, the repository itself, and all the associated metadata that has been installed on your Oracle server accurately matches what is currently and readily available on the official Linux website. because it could potentially be the case that your local repository isn't accurately matching or isn't completely in sync with the most recently updated content that is available on the website. So you update your packages, right? And after that, you run a command to perform an upgrade, to update those packages.